Have you ever wondered what happens inside an Oracle database when you run a query? Behind the scenes, Oracle has a powerful architecture made up of memory structures, background processes, and storage components, all working together to manage data reliably and efficiently. In this video, let's take a guided tour of the Oracle traditional database architecture. So, I am mentioning traditional. In 23 AI, Oracle brought up so many new features which is related to the AI era. So, before the 23 AI, so how the Oracle typical architecture looks like, how when user given query, how the query execution will happen inside that Oracle database, we will see in this particular video. Hey, hi all, welcome back to Data Surface. If you are watching this video for the first time, I would recommend please have a look at the previous videos existing in this playlist. Those videos will set up a stage for this particular video. Let's get into the today's topic. So it's all begin with the user. You as a developer or DBA connect to the Oracle using tools like SQL Plus, SQL Developer or any other IDE tools. This is called the client interface where the SQL statements are submitted to the database. Right? So this is where basically user give the request or enter the particular query to get the data from the database. So basically this is a interface where you can communicate with the Oracle database. Now once user given the request, a connection request is made, it is handled by the Oracle listener. So the listener configured using the listener.orf file accepts client request and establishes the connection to the database. Authentication can also be verified using the password file. After successful login, the listener hands over control to the Oracle server process. This is the kind of a workflow. When user give a request to the client interface, it will hand over to the listener. So the listener is made a connection with the database and the listener will authenticate the user by using the password file. Then it will start the Oracle server process. The Oracle server process is now in action. Its job is to pass and execute SQL queries on behalf of the user and to manage memory and disk interactions. To do this effectively, the Oracle server process, it will create an instance memory allocated area that we called as a database instance. In this, two major memory areas Oracle will use. The first one is PGA, Program Global Area. It is a private to each server process. It stores things like SQL work areas used for sorting and joins, session memory for user session data, and the private SQL area which contains bind variables and execution plans. In short, the PGA is dedicated memory for each session processing, which means every time whenever user is try to give any request to the database, the Oracle will create a separate session for that particular user, for that particular login. At that time, it will create. The next memory area is HGA, System Global Memory Area. So this is a kind of a heart for the Oracle architecture. So the entire query execution process will be happen inside this particular memory area. So on the other hand, the System Global Area is or HGA is shared across all users and processes. It's like the central memory hub of Oracle. So let's break down the key components inside this particular HGA. The first one is shared pool. So the shared pool catches passed SQL statements and database metadata. It includes the library cache where SQL and PL/SQL code is stored and the data dictionary cache where the stores information about database objects. This helps Oracle avoid reparsing queries again and again, improving performance. So what it means basically, whenever you give any particular SQL query to the Oracle server, so it will speed the particular query and it will parse it. The Oracle itself, it have a certain rules and regulations to check the particular query syntactically is accurate or not. So based on that particular rules, it will pass that. For example, if you are given query select star from EMP, right? So it will check that select query from where all having correct spelling or not, it is having proper order or not. So what are the columns you are giving properly, you are giving with the commas or not. So basically it will speed that particular query and it will check that it is aligned with the syntactical rules or not. If it is everything is aligned properly, then it will proceed further. So, in nutshell, the shared pool is basically having the main two components, library cache and dictionary cache. So, library cache is basically it will parse that SQL query, and dictionary cache is basically it will have all the metadata of objects, right? This is the one of the key component inside the system global memory area. So, now the next component is database buffer cache. So, the database buffer cache is when you query a table, Oracle doesn't fetch the data directly from disk every time. Instead, it keeps recently accessed data blocks in this particular cache. So, repeated queries are much faster. So, what it means, for example, user A is there, he queried that select star from EMP. Then user B also trying to access the same query. So, since the first user already accessed that particular query, when next time user B is trying to access the same data, so the Oracle, it has intelligence, it don't go directly to the disk. Instead of that, it will directly fetch the data from this particular buffer cache and it will give to the user. The next key component is radiolog buffer, which is inside the system global memory area. So, every change you make in the database, whether an insert, update or delete, it first recorded in the radiolog buffer. This ensures recoverability. Even before writing data into disk, Oracle guarantees that radio entries are safe. So, this is basically whenever if there is any system crash or any power failure happen, you just trying to execute a particular query. So, you just given update query to the Oracle database, you want to update particular employee details in the EMP table. Then after triggering that particular query, maybe due to power failure or maybe system crash is happened. So, that particular update or insert any entry will be going to store in this particular radiolog buffer. Once you log in back again, those records will be recovered from this particular radiolog buffer. Another key component is large pool. The large pool is an optional memory area that helps with the big memory operations. It is used by RMAN backups, parallel queries, shared server connections and input-output operations, preventing the shared pool from getting fragmented. So, this is basically, it will help with the big memory operations. So, it is like if you are dealing with a very huge data set, if that particular data set is not going to fit into the shared pool memory area for parsing and all, in such kind of scenarios, this large pool will helpful for us. Apart from this, HGA also includes the Java pool for the Java based objects, the streams pool for data replication and the small fixed HGA for control information. So, these are the pretty much key components which are available into the system global memory area. Now, let us talk about the background processes that keep Oracle running smoothly. So, these processes work silently to handle input type, output, recovery and memory management. So, the first one is database writer, DBWN, writes the modified data blocks from the buffer cache to the data files, right? So, if there are any records are modifying, you have given any insert or update. So, the modified data blocks from this particular buffer cache is going to store in the database storage. Now, LGWR, log writer, writes radiolog entries from the radiolog buffer to the online radiolog files. As I mentioned, the radiolog buffer is going to temporarily store the any DML statements, right? So, those logs, this LGWR is going to write into the radiolog files. Then checkpoint, so it is basically, it will coordinate with the database written and log writer to ensure data consistency by updating control files and data files during checkpoints. So, this checkpoint between database writer and log writer. And ARCN archiver copies the online radiolog files to the archive logs once they are full, essential for backup and recovery. So, this is a kind of a every time it will archive those radiolog files. If there are any system crashes, any hardware failures happen, you can recover those radiolog files from this particular archive radiolog files. So, the upper bound, there are MMON, SMON, PMON, right? So, these are the system monitor, process monitor, manageability monitors, right? The system monitors perform the instance recovery after a crash. Process monitor cleans up failed user process. Manageability monitor collect performance statistics. RECO, handled distributed transaction recovery, right? And other specialized process like MMNL and AQ process support advanced Oracle features. So these all are kind of a background process. It will run behind the scenes. It make that entire execution process smooth. Now coming down, so there are database storage components are there, right? All these process and memory structures eventually interact with the physical storage layer, which is made up of different types of files. So this is the basically where you can see the database storage, the actual data is going to store in that particular place. So there different types of files are there, and is the control files store metadata about the database like file location, checkpoints and log history. Data files hold the actual user and system data. That's where the data block where actual data is going to store. Radiolog files record all changes made to the database for crash recovery. Archive radiolog files generated by archive process for backups and disaster recovery. This is what we have discussed, right? In a hardware failure, major failure was happened, you can use this kind of a audit purpose. Flashback logs allow Oracle to rewind the database to previous point in time. So these are the key components working together inside the Oracle architecture to make it this entire execution process very smooth way, right? So putting it all together, user connects through the SQL developer or SQL star plus and give a request, and the connection through the listener establish the connection, and the server process execute SQL using PGA and SGA memory structure. Background process ensures the data is written safely on the disk, and storage files maintain both the current state and recovery options for the database. So this is how Oracle database architecture ensures performance, reliability and recovery. So this is what happened. And I put a simple word, just assume you are giving a select star from EMP through SQL developer via client interface. The listener, it will identify the login user is authorized user or not through the password file. Once the entered password and username is correct, it will allow to the login. Then it will establish the server process, and the server process basically use the two memory areas, program global memory area and system global memory area. Program global area is basically session specific, and where coming to the HGA is the core part. So that select query will come to the HGA and it will go to the shared pool, and the select query will be split into the multiple chunks, and it will validate all the syntax checks, everything. Then it will check that corresponding table is available or not in the database by using the data dictionary cache. Then it will go to the database buffer cache, and then through the database writer, it will go and it will check that particular corresponding data from the data blocks from the database basically, and it will fetch the data and it will come to the Radiolog buffer. Then it will give the output to the user. If any user next time is trying to get the same query, that result will be fetched from this particular database buffer cache, right? So this is the complete workflow. If you found this breakdown valuable, don't forget to subscribe to the Data Surface channel and hit the bell icon for further updates on database technologies. In our next video, we will deep dive about Oracle 23 AI architecture. Stay tuned. Thanks for watching. See you in next one.